Lesson 11.2, simplifying radical expressions. This is continued. I thought that there was way too much for one lesson to try and keep it all straight. Now, you look at this, and you might say, what's the big deal? It's already reduced. You can't get any of the perfect squares. Can't get any of those in there. So what's the problem? Well, the problem is we can't have radical in the denominator. Why not? We just can't. And the reason we can't is because we won't recognize it as a like term, as another radical. So we always put it on top. The nice news is it's very easy to do it. Just multiply it by 1. Also known as root 2 over root 2. And that's how cool math people say these. They don't say radical 2 or square root of 2. They say root 2 over root 2. So root 2 times root 2 on the bottom is just 2. And can't combine the top at all because one's inside the root and one's not. So it's just 5 root 2 over 2. That's it. That's how we rationalize. That's what it's called, rationalizing the denominator. Root 3b over root 3b. Now these we can combine because they're all under a radical, so we get 6b. And on the bottom we get 3b. You may be tempted at this point to reduce that because you see a b in the top and a b in the bottom, but you can't. The b on top is inside a radical. The 6 is inside a radical. On the bottom, the 3 and the b are outside the radical, so those are different animals. So just leave it alone. That's it. Now, adding and subtracting radicals. Not too hard. Key thing is, remember, have to have like terms. A like term means that you have the same radical. So this root 10 and this root 10 are like terms. So it's like saying 4 apples plus 6 apples is 10 apples. But we don't have apples, we have a root 10. And that's it. You look at these and you say, can't add them, stuck. Well, before you do that, see if you can reduce this one, the root 48. I happen to know that 16 times 3, and you can cheat because you know you're going to be able to add them, usually. I mean, what kind of idiot math teacher would ask you to add something that you can't add? So you get it down to 4 root 3, 5 root 3, and then you say, oh, those are like terms. 5 root 3s plus 4 root 3s is 9 root 3s. Try the next two on your own. Remember, this is really a plus minus. This is really a plus minus. You don't want to mess with those negatives if you can help it. See what you got to do. Now, you know this is going to be something times root 7. Go for it. So 12 root 7 plus negative 9 root 7. 12 minus 9 is 3 root 7. Tricky. Pause the tape, try the next one on your own if you want. And please remember, root 8 must be reduced. I can't tell you how many students don't reduce root 8 because it's a smaller number. They think, oh, no big deal. That's it. Hope you got the same answer. Remember, there's a invisible 1 right here. And last part. How do we multiply radical expressions? We distribute. Same thing we've been doing. Root 5 times 4 is 4 root 5. Notice we don't write root 5, 4, because it looks like the 4 is under the radical. That's it. Root 5 times root 20. We're multiplying root 5 and root 20. We can put them under the radical. 5 times 20 is 100. Think we're done? Never. 4 root 5 minus 10. And this I would accept, but some evil math teachers might not. They usually want the real part before the imaginary part. Or pardon me, the irrational part. But either way, I'll take it. Now we got to FOIL a bunch of times. Try that without me, then I'll come back and do it for you. Pause the recording. Seven minus 6 is 1. Negative 3 plus 1 is negative 2 root 14. These are tricky, especially on top of the other ones. There is a lot of material here. But practice, you get good at it. Good luck.